Okay, so this problem is going to be about conservation of momentum in an inelastic collision problem. So let's give it a read. Bob is a 30-kilogram boy. He is running at 4 meters per second when he jumps onto a 10-kilogram sled initially at rest on a frozen lake, so we can ignore friction. What is the velocity of Bob and the sled after he jumps on? So what we're going to want to think about is the initial momentum is equal to the final momentum, because momentum is always conserved. And so what momentum is equal to is this P here, and what that is its mass times the velocity. So it is going to be mass 1 times velocity 1, and this is going to be for Bob, plus the mass 2 of the sled times the velocity of the sled. And since Bob is jumping on the sled, they are going to be treated as if they were stuck together. So on the other side of the equation, it's going to look like mass 1 of Bob plus the mass 2 of the sled times the velocity final after he jumps on. And before we start algebraically moving stuff around, we are going to notice that initially the sled is at rest, so the velocity is 0, so it's going to make this whole term right here become 0. So now what we want to solve for is the final velocity of Bob plus the sled. So what we're going to do is we are going to divide over the mass of Bob plus the mass of the sled and divide that by the mass of Bob plus his times his velocity. So what it's going to look like is the velocity final is going to equal the mass of Bob times the velocity of Bob divided by mass of Bob plus the mass of the sled. And so what we're going to get here is, so Bob is 30 kilograms times that by his velocity, which is 4 meters per second, divided by Bob, which is 30, plus the 10 kilograms of the sled. So that is going to be 120 divided by 40, and we will get 3 meters per second for Bob and the sled after he jumps on. Please leave some comments as to how I can make these videos better. I'd really appreciate it. Thanks a lot.